We are the Roboraiders, Team 446 from Honolulu, Hawaii. Our presentation today is about water displacement.
Before we get started, here's some brochures to help you understand our presentation.
Congrats to winning state students. Y'all worked very hard this year, turning in exemplary summer research reports and doing magnificent outreach to the communications to other teams and talking to experts like Dr. Chip Fletcher, Dr. John Rooney, Dr. Bruce Applegate, and Ken Kawahara, the Deputy Director of the State of Hawaii's Commission on Water Resource Management. It's time to start thinking about Dayton.
Now, how can we get across the problem of water displacement to the judges there? Remember that water displacement is the problem of having too much water in one place and not enough in another.
Well, I think we should start like this. Often, in tropical Hawaii, seasonal excess rainfall leads to the flooding and destruction of properties. In 2006, half of our school's campus was flooded by heavy rains. From that, you can definitely tell that we're affected by this.
We forgot about drought. Listen to this. Droughts in Hawaii shorten crop yields, diminish livestock herds, and desiccate streams and irrigation ditches. Our droughts are caused by a lack of rainfall and taking fresh water out of the ground too quickly.
But what about other countries? Japan and Australia are both experiencing drought too. According to our contact, Mr. Barrett Cameron in Australia, some people there can't even grow vegetables or wash their cars.
Did you guys do any more research to a solution to water displacement?
I did some research on cloud seeding. It isn't such a great solution because it doesn't last very long. Additionally, an advisor to Mr. Ken Kawahara, who has a background in meteorology, told us that cloud seeding has not been proven to work.
A water catchment system for a homeowner makes more sense. Hawaii, because of its high annual rainfall total, will be the perfect place to put a water catchment system.
Well, a bigger solution is even more awesome. We could filter the stormwater using two types of filters, a membrane bioreactor and reverse osmosis. Reverse osmosis, by the way, is when water is sent out through tiny holes, filtering the good water from the dirty water.
It sure sounds like you've done a lot as individuals, but what have you done as a team?
Well, we all work together on these two models, which show how we can take stormwater and use it during periods of drought.
Check this out. When it rains, the water flows off the roof into a gutter, which is then turned into a rain barrel. There is also a water catchment system under the yard. The water from that is then put into a cistern underneath the house, pumped into the house, filtered, and can be used in things like toilets.
But that's not all. This half of the model is our large-scale solution. If it rains on the street, the water flows into the storm drain, being wasted. However, if we can divert that to a membrane bioreactor facility, we can reuse the water.
Here you can see the oil and sediment separation sections. The water is then pumped up through 3 filters: a reticulate filter, a biological filter, and finally reverse osmosis. The result is water that can be used for uses such as irrigation. These two systems would make up our water-conserving neighborhoods of the future.
You know, a good place for a membrane bioreactor facility would be a golf course. I contacted the Hawaii State Public Golf Course Director and the Board of Water Supply and attempted to convince them to install a membrane bioreactor on the Alawai Golf Course. Unfortunately, neither group wanted to pay for the high installation cost, about $3 million according to the University of Hawaii School of Engineering, although the system would pay itself off in about 6 years.
But do you know where we're going to put our more local solution? I contacted 150 schools across the state of Hawaii, asking them about water catchment systems. 51 schools responded. 38 schools said that they are thinking of getting water catchments. 6 schools said they already have water catchment systems, and 8 schools said that they are not interested in getting one.
I compared high total rainfall and high population densities on the island of Oahu to find the 5 best places for our water catchment solution, shown in blue. Look at the correlation with Cordy's data points. Remember how much fun we had sharing all of this information with the public?
Yeah, we went to Whole Foods and shared our project with the people there and presented at the ELI School Fair. We wrote a letter to the mayor and received one too, and had a published letter to the editor in the Honolulu Advertiser.
Great job, everyone. You've all worked so hard on this that I can hardly believe it's the same presentation. Now all we need is a good ending. How about something like, we have all of this water, so we should use it towards...